So what you can do here is, as you said, fine-tune your own LLM on your own data set.
All right. Hey, welcome, Pascal Pfeiffer. We have on the show today. I'm very excited to talk to him. Pascal is a PhD in electrical engineering. He's the principal data scientist at h2o.ai, where he's responsible for a number of products, including LLM Studio, Hydrogen Torch, Label Genie, and a number of other responsibilities. He's also a Kaggle competition grandmaster, which I'm very, very excited to talk to him about that as well. So welcome. Thank you so much for joining me.
Thanks for having me here, Matthew. Very happy to be here.
Well, let's jump right in. I did a video a few days ago about H2O GPT and specifically the Falcon model. And why don't we start from a high level? What is H2O AI? What do you guys do? And then we'll dive a little bit deeper into each of the products.
Sure. Well, actually, H2O AI was founded already about 10 years ago, and it started out with some products that were mostly open sourced, including statistics, yeah, data science tools all over it, and then yeah, transitioned into that AutoML side, which is now very famous for. So we have a strong open source pool of products on AutoML side, and then also obviously some closed source enterprise solutions. The most famous one probably being driverless AI, which is almost a one-click solution to build your machine learning models in kind of a leaderboard, and you just press a button, feed your data, and get the best model out there. And yeah, over the years, H2O AI has gathered a lot of Kaggle Grandmasters in their employee count, which yeah, helped them to include like the most cutting edge technology into the products, and that's why I'm so happy to be there on the team, because it's quite fun to work with other Kaggle grandmasters and masters, and yeah, obviously Kaggle people on creating new products that are making or that are pushing the AI frontier further every day.
Yeah, and we're gonna dive into like what is Kaggle, what does a Kaggle Grandmaster mean, and what are these competitions. But first, I want to hear more about H2O. When I think about H2O from the website and from talking to you and a couple other folks at H2O, it is seemingly mainly a business to business artificial intelligence company. Is that correct?
Yeah, that's true. For the enterprise solution, that's definitely what we are focusing on. So it's really just business to business, and with AI Cloud as the main product here. But with the open source tools that we are offering, we are actually targeting everyone, and you see that right now with the fine-tuned Falcon models, for example, that you just mentioned, and the two repositories that were pushed out for LLM tuning. So these can be used by everyone basically, and they can be run on the single GPU on your home computer basically, or even on some cloud hardware such as Google Colab.
And so the for the video that I created, I used H2O GPT, which was hosted by you, and that was using a fine-tuned or an optimized version of Falcon. My first question is, how did you get Falcon to actually be as fast as you did? Because I have a previous video where I reviewed Falcon specifically. I put it on RunPod on a beefy GPU, and it was brutally slow, unusably slow. I couldn't even test it. So, what are some of the techniques that you use to get it to be actually fast and usable?
That's a good question. Yeah, inference is basically always slow with these kind of transformer architectures, because you're generating each token at a time, only one token at a time, and then you go to the next token and so on. So, but yeah, it's naturally a slow process. But there are a couple of tricks, and I don't want to take the credit here for this because it's basically using Hugging Face technology in the background from that awesome library that was also open sourced by Hugging Face. So we are kind of building up on each other here. This is called text generation inference, and it's using the flash attention mechanism as a drop-in replacement for the actual attention mechanism that was used in the Falcon model. And that is fusing the steps in attention together to a single one or to a single operation, which speeds up the whole process of inference a lot. So that's basically what it's doing as a main thing to make this whole process of inference faster. And then there are also some other tricks that we actually didn't even use in this deployment, which would be, for example, tensor parallel, where you can split the whole process onto or the whole tensor multiplications onto multiple GPUs. So parallelizing the entire process here, which also would make it a bit faster. But the deployment that you have tried was actually a single GPU deployment. So it's mainly the flash attention which is making it so fast.
Okay, and so you have this optimized Falcon model that you're hosting that is what I reviewed, but you're also saying I can download that and run it on like text generation web UI, for example, or any whatever software I'm running it on locally.
Exactly, yeah. I mean,
And it,
we are pushing these weights to the Hugging Face hub, where nowadays almost every model is being pushed to. So all the open source community probably pushes their model weights to Hugging Face hub, and that's where we are also publishing our models. I think we have around 20 right now being pushed there. And you
awesome.
can basically go to the model card for each model, and you see already a default pipeline that you can use, just a few lines of code to get it running.
Okay, and you had a separate website, a separate version of H2O GPT, and I'm forgetting the name of it, so forgive me. But we were able to upload our own data and kind of do an additional, provide additional context to the model that it could read from. What was that called again? And then can you talk a little bit about what it takes to essentially chat with your own documents?
Yeah, that's probably gpt.h2o.ai
That's right.
that you were using. Yeah.
Yep.
And that's it's a Gradio interface, and also uses a lot of the open source tools that were built in the last few months. So there has been tons of repositories popping up every day. And one of the main repositories that was released quite quickly was called LangChain,
Hmm.
which kind of glues together all the pieces used for LLMs and making LLMs actually usable in the context of more data. So if you want to ask questions about your own data, you obviously need to first upload this data, but then it needs to be converted to some new style how you can ingest it into your LLMs. And that's first of all some kind of scraping. So if it's just PDFs, you would scrape that information from the PDFs and transform it to some text file. But still, it would be hard to feed all of this data into your LLMs because the LLMs do have a maximum context length. So you probably need to chunk all of this data first in smaller chunks to make it ingestible by the LLMs. And then you would still need some logic to pick the correct chunk. Because if you ask a question about a long document, which is, I don't know, let it be 100 pages, and you ask a question, it's a financial report maybe, and you ask about the quarterly results 2022. So somewhere in that document, there is probably the answer to that question,
Hmm.
but you don't want to go through the whole document and feed it chunk by chunk to your LLM. It would take ages. And everyone knows about the problems of hallucinations in LLMs. So you will come up with a lot of wrong answers, most likely. And that's where LangChain and also some other solutions help by having an embeddings database in the background. So with each chunk, you embed it into a vector space of just a few or just a few dimensions, maybe let's say 1,000 dimensions, and these can then be compared to the question that you are asking. So if it's in the highly dimensional vector space close to the question that you're asking, or the closest to the question you're asking, the original text will be fed to the LLM as a context, and the question is basically repeated to the LLM again with that context being attached. So
So
then, yeah,
if I had to summarize kind of the high level workflow there, you have a PDF, it gets chunked and put in a vector database, and then when somebody has a query for it, first you query against the vector database to get the relevant pieces, so you're not passing that entire document into a very limited context window. Then with the question, and then with all that context, with the relevant context only, that gets passed into the large language model to then give us the response.
exactly, yeah, and that
Okay.
can not only be one context. Maybe if you have two good options or three good options, that would also be working to feed that as additional context to your LLM actually.
Okay.
And I mean, you could even try some more sophisticated methods and do some summarization first, or ask the question towards each chunk. But yeah, all of this is additional yeah, some overhead in computing. And yeah, as probably if it's a time demanding task, you don't have all the time of the world, and you probably want to go with the easiest method first.
Yeah, and on this note, I have a question for you. So one thing I've been thinking a lot about is projects like GPT Engineer and small developer, essentially projects where you can put in a prompt and they create code bases for you. And they're pretty limited for the most part. And generally, one of the most kind of frustrating limitations is that you can't build on top of an existing code base. And with that, that means you can't iterate. So, for example, if you put out a prompt and you get a code base back, you can't say, oh, actually, I wanted this file to actually operate like XYZ. And I understand why, because at a certain size, code bases become very difficult to pass into a single prompt. And so, maybe just from a high level, how would you solve that problem using a vector database? And would it be a vector database? This is something that I've been thinking so much about. I would love to get your take on it. And basically, the question being, how do you pass large code bases to a large language model to give it all the context necessary to actually write good code?
That's actually a very, very good question and a super tough one, I believe. I I don't think that this is really solved yet. Even with yeah, nowadays co-workers or co-pilots such as yeah GitHub
Copilot, yeah.
Copilot X, for example, they are still quite limited in
Yeah,
ingesting the entire repository. If it's really a lot of code, hundreds and hundreds of pages, this is basically not solved yet, I believe. Because you can, for example, add it to the vector database, but you would still have so many dependencies that you just can't put into a
right,
single prompt. Um, I mean, it's even tough for engineers. If you do change something and it requires you to touch quite a few places in the code, you can't do it in one step. It's really an iterative
right.
process, and you need to write down stuff, you need to test it, debug it, and all of this. And as LLM models or LLMs are something or more like zero shot, they just yeah, have a single approach and that needs to fit. I think this is super tough by having a vector database here in the background. I think one solution could be the ultra large context sizes, which are being developed right now. So we are seeing 60K, 100K as context size, and there have been some development on million tokens context length too.
Mhm.
I haven't personally looked into that too much, but I think that's yeah, maybe the only way how to actually solve this. And then maybe it's not even enough to do a single shot or zero shot prompting and answering here, but rather more sophisticated ideas such as the yeah not only chain of thought but maybe even the tree of thought method. So you would actually go down multiple routes and then only in the end decide which one will actually solve your problem the best way it could. Yeah, and maybe even with added playground sandbox mode. I don't know. I think code is really the the most toughest or the toughest yeah challenge or task for these models.
Yeah, I mean, especially when you're talking about code bases that are kind of highly intertwined, and if you have a very modular and service-oriented code base, maybe it gets a little bit easier. But one kind of theoretical way I was thinking about solving this, and again, just an idea, is almost having like a map of the code base that could be generated by ChatGPT, that could be generated by a large language model. So essentially, translating a really large code base into just definitions of methods, definitions or high-level overviews of files, and within that definition, maybe you have here are the parameters this takes, here's the expected output and the format of that output. And then maybe that'll be the translation layer between the query to the vector database, and then finally to the large language model. But I don't know what that map would actually look like. What do you think about that potential solution?
It's a nice idea actually,
Yeah.
and I think it somehow is what C++ and other languages are doing it. So you basically write your header file. You have maybe even some doc strings for each method or for each function for each class, but you don't really write down the code for each of these methods. You only have the yeah as you said the yeah a top level explanation for each. I
Yeah.
think it could be a good way to connect all the pieces together. Still, if it's super clean code, I guess that could work. But in reality, maybe it's a bit tougher than this, and it's not always the cleanest solution. And doc strings can be wrong, even if they are, or maybe especially if they are auto-generated. So if you add, like you said, a first layer pass would be to summarize each function into some documentation, some high level documentation for this. Yeah, it would be a nice idea to test out actually.
Yeah, I mean, this seems like the holy grail of coding
Yeah.
assistance, right? If you're able to naturally work and iterate on a piece of the code, that would be wonderful. I mean, personally, I use ChatGPT for coding every day. And so if it actually had the context of my entire code base that I was working with, it would become exponentially more powerful and productive for me. So that I would love to see someone solve that. It's something I'm definitely thinking through.
Yeah, I think many people are looking for this right now.
Yeah.
Um, yeah. I mean, having some kind of junior programmer or pair programmer here as an AI, it would be really the dream. And that could make everyone like the 10x engineer, I guess, or the
Yeah.
10x coder.
That's right.
Yeah, it's super tough. Yeah.
Well, I want to continue talking about open source and the state of open source. There's been a lot of, I wouldn't say controversy, but a lot of discussions around, how far along are we with open source large language models? Some people think they're getting within, single digit percentages in performance to ChatGPT 3.5, maybe ChatGPT 4. Others are saying, there was a paper, I'm forgetting what it was called, the false promise of open source large language models, something like that. But essentially, large language models that are open source are effectively really good at mimicking kind of prompt output, but aren't necessarily deeply understanding the logic and how to arrive at conclusions. So, what's your take on the state of open source and how they compare to proprietary models?
That's a tough one. Good question too. I think open source always wins in the long run because it's such a huge crowdsourced base here, and maybe even the data is the most important here, which obviously open source excels in comparison to closed source solutions. But yeah, ChatGPT does have a strong lead here right now. So especially GPT-4 is definitely the top one LLM right now because it
Yeah.
has such a broad range of applications. You can use it for almost anything, including very tough coding, as you said. So if you use it every day, it's probably good, and it doesn't make too many mistakes there.
Right.
And that's also what I have experienced here. Even with some newer frameworks, it's pretty decent, I would say. And open source really catches up to this, especially if for the non-coding stuff. I think that most of the answers or most of these questions that we ask ChatGPT every day, or that are mostly asked, can also be solved by some smaller models such as Vicuna or I mean these 13 billion, 30 billion, 40 billion, 60 billion maybe these models. So that works quite nicely, I would say. But it's probably also do some kind of distillation. So knowledge distillation is really a big factor here. Because people have been fine tuning on data that was generated basically by ChatGPT or very similar styles. So I think mimicking is the right word here actually. What we are doing in open source currently, we're trying to get that level of GPT-4, but making that last step, I think that will need quite a bit more thought. And yeah, the second one, the second thing that you were saying was about the last digit. I mean, we read the papers. We are at 99% of GPT-4 or GPT 3.5, which is always needs to be taken with a grain of salt too, because
Yeah.
I mean, on which kind of questions was this asked? How was it evaluated? Was it by human evaluation? Did they go through the code line by line and checked everything, or was it just, oh, this answer is a little bit longer than the other one, so it must be better? I think there is always a lot of bias, even in human review. So yeah, I would take it with a grain of salt.
And looking at the architecture of what could potentially allow open source smaller models to compete with GPT-4, do you think it's going to be like many verticalized smaller models, highly fine-tuned models in certain subjects that are coordinated by like I think it was called a Hugging GPT was Hugging Face's version of this, but essentially kind of a generalized brain in the center and then lots of fine-tuned, highly verticalized models. Do you think that's going to allow us to get to something more comparable to GPT-4? Because GPT-4 is, just looking at it from the outside, it's one interface. You just hit one endpoint and it can cover so many different topics. But maybe that's just not how open source is going to work. So, what do you think about the architecture that'll allow open source to compete?
Yeah, that could be one of the solutions for sure. Obviously, it's not super easy to distribute this to across multiple models because it would need a very strong classifier here, even
Mhm.
for unexpected prompts, maybe. But yeah, I can see how some models really excel on specific tasks, and that how that can be distributed. I think there was also some posts about the actual architecture of GPT-4 lately. So apparently it's
Yes,
also
I want to talk
not a
about
single
that.
apparently it's also not a single model, or maybe at least there is this rumor. So yeah, I think I think it makes sense to distribute a little bit. And what we also see in Kaggle all of the time is that blending or mixing models is almost always a good idea.
Okay, let's talk about that for a minute because the blending, I believe, is what again, this is third party news. This isn't actually coming from OpenAI. But yeah, so in the last couple of days, there has been what some would call a leak of information of what the architecture of GPT-4 looks like. I believe, and correct me if I'm wrong, I don't have the stat in front of me, but it's 200 billion parameter models. Does that sound correct?
Yeah, 8 times 220, I believe, was said.
Hmm.
But yeah, again, as you said, it's not first from
Right.
first hand, so it's a rumor here. Yeah,
Let's assume that's true. First of all, what does that actually mean? And when you're mixing models together, how does that work? Explain to me because I've never heard of this before. So maybe you can explain it as simply as possible to me.
yeah, there are different ways, and I'm not 100% sure how I should understand that tweet actually. It could be, or that interview that was then later tweeted. I think it could be either that they are really just mixing the predictions, so they are running these 8 models in parallel, and they are just adding up or averaging the logits of the output tokens. So then, yeah, this would also be already be a seed blend, for example. So in usual modeling or machine learning, you can just train a model 8 times and then average the results of the same. It's basically the same model just trained 8 times, and that's
On the
almost
same data set.
on the same data set. Yeah,
And so
that is one
it
solution.
sorry to interrupt, but so if you're training the same model 8 separate times on the same data set, you're going to get 8 separate results, 8 separate final outputs.
Yes, I mean they are all in a range. They are not super different from each other. But yeah, blending or averaging can be mean average, can be vote average, anything probably. Averaging these 8 models already gives you a better final outcome than yeah, each of the 8 models individually. I mean,
Wow.
there could be some occurrences when a single model does give the best answer, but on average, the average of the 8 should be better than each single model on its own.
Okay.
So
And I oh please.
yeah, yeah. I mean, this is actually one of the very common strategies that is used in at Kaggle,
I
where
was
you're
just going to
really
ask about
pushing,
that.
yeah, where you're really pushing for the last digit here or for the last bit of accuracy. So it's nothing that you would usually do in production because it means you're spending 8 times as much money on inference costs here.
Right.
But if you really want to go for that last mile or that last digit, it could make the difference here to just back multiple seats of the same model. So that's,
Got
yeah.
it. Got it. Okay. So on that, I want to talk about for a second. We're going to come back to that. What is Kaggle? You are a Kaggle Grandmaster. I want to talk about what that means. But first, from the highest level, what is Kaggle?
Maybe I want to go back one step to the last question first, about the blending. So what
Sure.
could also be what was obviously, and we already covered it shortly, was that this is actually 8 individual models that are different from each other and also have been trained on different data. And then there is a single model on top of it which distributes the work based on the prompt that was asked. So that is also a possible solution, and I have no idea which one it is actually. Maybe it's
Right.
both. I don't know.
Yeah.
But yeah,
Yeah. Interesting.
but no, yeah, yeah. Going back to or going to Kaggle then, answering this question. So Kaggle on a very high level is, yeah, I think a data science platform where people can compete on various competitions that are, yeah, actually being tasked by bigger companies. So there are Microsoft, Facebook, all the bigger companies, and also of course smaller companies that are yeah, hosting a competition there. It's always some kind of data science competition, and it's about all different topics in data science. It can be object detection, it can be text classification, it can be some, yeah, nowadays LLMs, LLM tasks. It can be something about generative AI as a whole. And then yeah, you get tasked with or you get a data set, and with that data set, you are tasked to create a model, and this model is then scored to with a public leaderboard or with a public test set, and in the end also with a very hidden private test set, which you never actually see before it gets revealed on the last day. Yeah, and this Kaggle platform basically is the provider or the platform where all of this is happening. And I think now it's about 10 million, 10, I think 10 million users even on the platform, competing with each other, but also sharing knowledge. So lots of about this platform is sharing knowledge about newest discoveries in machine learning and data science.
So maybe a good example might be Netflix wants to improve their algorithm by 5 to 10%. I know that they've had competitions in the past. I forget if they're internal or external, but let's say their data science team is busy, and then Netflix says, okay, we're going to outsource this to Kaggle, make it a competition. There's going to be a prize, and they provide a subset of their data to run it on, and everybody, data scientists, can join and essentially try to compete to get the highest improvement in whatever their metric is, retention, for example. Is that a good example?
Yeah, that's correct. I mean, mostly these companies are not sharing their actual data because it's
Right.
highly classified. So they either scramble it somehow, so anonymize it somehow, which is sometimes possible. But sometimes they also just interested in some algorithms. So they give you some random data or made up fake data, which is always kind of re-engineered then in in these competitions. So yeah, I think there are, yeah, quite a few use cases that you can think of. Many of these competitions are not on very classified data, but rather very open data, which you could also get somewhere else, and they are happy to share it.
Okay. And so, how did you get into Kaggle? How did you find it? How did you start to compete in the competitions?
Actually, it was in the one of I think the last year of my PhD studies, where I was always very interested in automating stuff, and yeah, writing my own little scripts to automate most of what I'm doing. So that's where I was, yeah, getting interested in machine learning, and how it can, yeah, I mean, it could automate, or it can do some yeah, I mean, you would know more about your data without being biased yourself, and all of this. So first I was getting a book for machine learning and started reading it. But everything was already so done. I mean, the tutorials, they're easy to follow if you know what's happening. But it wasn't really showing what is data science, or what is the real difficulties, the real issues to solve here. So I was looking for ideas, what kind of problems are others solving with machine learning, and then I stumbled upon Kaggle. Found it very interesting because you couldn't actually see the test before it was released in the end. So you would need to think of proper validation, um, proper setup of your entire pipeline before actually, yeah, starting with your endeavor. So yeah, I just thought to myself, why not, yeah, start on this platform and try to learn it while doing something, rather than reading a textbook. And I was already hooked in the first competition there. I think it was really strong with the sharing community of Kaggle. So everyone was looking through the same data. Through the same data. Everyone had these. It was only, I think, 40 megabytes of data back then. Everyone was looking for clues in there and was sharing what they found. And then there is also these public notebooks. So you can actually write a Jupyter notebook there on Kaggle and share it with the community, so everyone can see what kind of code you are writing, and how you're tackling the task. And yeah, that I think sped up the whole process of me learning machine learning, um, by just using Kaggle and competing in these competitions.
So, can you walk me through what a typical competition might look like? What, like from the very beginning, what is the description? Are there goals? Then they provide data. What does that whole workflow look like?
It's usually just the data that is given first, with a very strict evaluation pipeline or metric. So that's already set up. All of this is set up right from the beginning. You get let's say it's a image classification task. So in this case, you're getting all of the train images. Then you're getting the say it's 10 classes, and it needs to be distributed to these 10 classes. So you are usually provided a CSV file or some kind of key value pair here for each image. This is the label, and then you already have everything that you need to build a pipeline from that. So you can train your own model. Maybe take an efficient net or something, strap on a classification header on top of it, and then train this image classifier. And usually, what's done then is, these are called code competitions nowadays, which has become quite the norm. So you actually submit all your code that is able to run new predictions on unseen data. So it has a given structure for test data even. And this test data is then ingested by your pipeline, um, run through your entire pipeline, and needs to produce another, in this case, CSV file, which is called the submission CSV file, and also has this key value pairs. So for each image name, this is the class that is predicted by your model. And this you're submitting to Kaggle. Then you get usually 5 submissions per day, so you can't overfit too much on the test data here, on the public test data. And then you get a nice ranking there, which is also very I mean, if you see that you're climbing the leaderboard, even if it's just public leaderboard, it's something that keeps you going.
Yeah.
So they really know how to gamificate the gamification for this whole process. It's really strong
Uh,
on that side.
and is there a monetary reward as well?
There is. I mean, there are some competitions even with $1 million and more,
Wow.
that is being distributed to the winners. And winners means, in this case, usually top X teams, sometimes 3 teams, sometimes top 10 teams, etc. But usually nowadays it's about $50,000 dollars per competition, which is then distributed across the winners.
And so, what makes somebody's code better than another team's? Like what differentiators are you typically looking for to be the best model or the best code?
Yeah, that completely depends on the competition. So if the hosts are very interested in, let's say, the F1 metric, it's that metric that you're being tasked with. So the best F1 metric on the classification task will in this case win the competition. But it can be anything. And there have been some very, very strange metrics, even which have been even debunked by the community. So if they don't make any sense, it has also happened that the metric has been changed in the, let's say, the first 2 weeks of the competition start because it was such a bad fit for the actual task. But that's yeah something that I really find very interesting at Kaggle. The whole point of creating metrics and striving for the best score here, which in my opinion is not always fully connected to the business goal. Because in some cases, yeah, you might think F1 metric is a good fit or good proxy for what I'm actually looking for. But then if you look closer, it might be something a little bit different that you actually should improve on if you want to maximize your business goal.
And what does it take to become a grandmaster? What do you need to achieve to get the title?
Actually, let me check. I think for Kaggle competition grandmaster, it's I think 5 gold medals.
Uh-huh.
Gold medals is distributed to the top 10, I think, top 10 teams from one competition, and then there is one extra gold medal for each 500, 100 competitors. I don't even know, to be honest,
Okay.
but I think it's 5 gold medals to become a competition grandmaster, and one of the gold medals needs to be a solo gold, so you can't be in a team for that one.
Okay.
Um,
And let's say I'm not knowledgeable about data science, but I want to get into it. I want to potentially compete in Kaggle competitions. What should I do? What are those first steps to start learning?
Yeah, I think always good start is to just join a competition, and then read through all of the public kernels that are being published, and not just fork them, copy them, and run them again, but really just yeah go through the kernels line by line and try to understand what they are solving, and also try to follow with the conversation with the discussions there about what is yeah becoming a strong signal in the data, what might be some bias in the data, and it's really a lot about yeah getting the noise, yeah, reduce the noise from all of what is being discussed to actually what is yeah the strong signal in the data and what to look for. I think
Okay.
just keep on learning is the most fundamental thing, especially with AI changing so rapidly.
Yeah.
I think it's even funny to call it AI nowadays, since until last year I was really afraid calling it AI, just yeah saying machine learning to all of it.
Right.
Uh, so yeah, I think yeah, what I did over all the years that I competed on Kaggle was to always try to learn new stuff, and that's what kept me on the page actually.
Awesome. So the last thing I want to talk about is LLM Studio. One of the biggest requests that I get in the comments of my videos, and I still haven't covered it, and we could talk a little bit about why, is how to fine tune your own data. I think a lot of people think they want to fine tune their own models, but providing more context in the prompt, being able to spin up a vector database and providing additional context like that is probably sufficient for 99% of use cases. But there is there is a need to fine tune models on private data or any data. And so I want to talk a little bit about LLM Studio. Maybe you can give us a quick demo and talk to us about what that fine tuning process looks like.
Okay, so yeah, this is LLM Studio that we have been working on in the last weeks, or I think it has been months now even. So what you can do here is, as you said, fine tune your own LLM on your own data set. And what most people are interested in is actually creating some kind of chatbot interface, or it's some kind of chatbot that answers on very human-like questions or instructions and does exactly this. But I think there is much more to fine-tuning, and it has also been checked in the last months, which is for example, calling an API, especially with LLMs, or transforming text into a key value pair or a JSON string. So these are also some use cases where you could fine tune an LLM on exactly that style. And I think Philip, he was also very involved into LLM Studio. He phrased it quite nicely in one of the latest tweets that he posted, that fine tuning is only about learning some kind of style. You still have the foundation model, for example, this Falcon 40 billion, which was trained on 1 trillion tokens. And that has all the knowledge already in it. The fine tuning on top is only done on a few thousand, maybe millions of tokens, and it only learns the style of the output of the input output pairs, or how the continuation of the text is being done.
Hmm.
And in this case, let's say we have a data set, and we have one here in LLM Studio by default, which is also the very nice open source OASST data set. And that one consists of always some kind of instruction and then an output. So it's really that very basic chat interface that you're looking for here.
And
So let's
is
say
this always the structure of the fine tuning data set? Is it key value, instruction, output?
It could. It's what LLM Studio is focusing on,
Okay.
but you could use it for other tasks. And yeah, I said you could, for example, train it on something that ingests a bigger data blob, maybe a page, or a text page, and then it outputs key value pairs as a string, or as a JSON string. So then you would format this completely different. It would not be a question answer thing, but it would rather be context plus key value pairs, something like
Okay.
this. But this is highly optimized for question answering in this case, because I think that's what most people are looking for nowadays. And yeah, it has this structure of having a question, having an answer, and what it also can do is having some kind of chains here. So if you have a full conversation, it can also have a parent ID, so a follow-up question in this case. And with these data sets, and I have this default data set here, you can then create an experiment where you say which data set you want to train on. In this case, it's just OASST, and you want to train a causal language model, which is exactly what we are talking about when we talk about these decoder-only transformer structures, where you predict basically the next token based on all the tokens that you have before. Give it some experiment name, and then you choose probably the most important setting to train an LLM, or to fine tune an LLM, which is the backbone that it should be using. So this is, as I said, all the knowledge that has already been trained on lots of GPU hours. So you can, yeah, select one of the defaults, but also some of the newer ones. So if you want to use the Falcon model, for example, you can
Mm.
just type it in here, and let's look it up. Okay, that's okay. I'm only sharing the screen, right? Okay, but you can basically use any backbone here that you want
Okay.
from Hugging Face, and then yeah, even personalize it. So you can give the chatbot a name, give it an author name, and it will replace these occurrences in the training data. So if you ask it later, what's your name, it will answer with this. And there are a lot of different, a lot of more settings, and I don't want to go through all of them
Sure.
now, I
Yeah.
guess. But yeah, some more important ones, in my opinion, are um, these extra tokens that we are using to tell the model basically when the text prompt or the user prompt is starting and when the answer of the bot should be starting. So I think this is something very important to teach the model the difference between a user prompt and an actual answer. And hand in hand with that goes the end of the sentence token. So are we going to add an end of sentence token after the prompt and after the answer? And after the answer helps the model to stop itself. So if you would ask a foundation model a question, it it may be answering this question even, but then usually the models, these foundation models, they go on in brabbling and talking more and
Right.
more about this and not really stopping at where they should be stopping. And that's basically what this end of sentence token is teaching to the model. So the model itself would learn, or the fine-tuned model would learn when to stop, and the answer is already done. Um, yeah, then you could go through the tokenizer settings. How long should the input be at maximum? When should it be cutted? You can use fast and slow tokenizer, and then we offer different quantization methods. So usually everything is trained on float 32. But if you have maybe a consumer graphics card with only 8 GB of RAM, you would probably want to go to some quantization methods, like this int4, which yeah, quantizes each tensor lower to a much smaller memory footprint without yeah, without hurting the performance or the precision too much. This is probably only possible because we are using LoRa in the background, which is this low rank adaptation. I think you've already covered it in quite a few other videos, I guess.
Okay.
But just as a quick recap, this adds another parallel path to each or to selected linear layers. So if you have a linear layer between two highly dimensional layers of your neural network, this is X by Y matrix. And if X and Y are both very large, this matrix gets super large. And if you want to do the fine tuning on that, you need to save the optimizer states or the gradients for each of these weights. And what LoRa does, it just freezes the original matrix and then adds this parallel matrix to this original one, which is a downcast from X to R. So this LoRa R is then denoting yeah, a very small number, and then this is being upcast again to the second dimension, which would be in this case y again. So then you have two matrices. One is x by 4 or x by r, and the other one is r by y, which is in total much less weights than the original one. And this basically allows us to fine tune these super large language models on consumer hardware or on yeah, much lower memory footprint that was used for the foundational training.
Got it.
And yeah, if you then set all of this up, yeah, you can choose some different metrics here: perplexity, voice score. Even ask GPT 3.5 about its score for each sample. You can run the experiment, and you can even run it on multiple GPUs because we are supporting DDP, so data distributed data parallel here. Yeah, and then basically run your experiment on all of your GPUs. And this is actually quite fast. So if you have a look here, this is one of our Falcon models being trained here, the 7B. It runs quite fast in about 3 hours
Wow.
on these three GPUs that I'm using here. And actually, let me see. So this, yeah, should be running here. So the 2.8 billion model will finish in about 30 minutes, which is quite fast, I would say. And you can actually see how the batch loss, yes, is improving here or going down while this is training. Have a look at the logs even here, what it's doing in the background. And everything of this is fully open source. So I don't know if you shared the link already or could do so later. So
I'll
please,
put it in the description. Everything we
nice,
talked about will be in the description.
nice. So yeah, everything of this can be fully customized, and if there's something unclear, just give us a notice, an issue on GitHub, and we'll come back to this. So if you then finish your experiment, you could even go ahead and yeah, let's go to this model here and use the chat window. So this is actually
Oh,
a
you could
model
test it
that I
out right
was
there.
yeah that I was training earlier, and you can go ahead and okay, I could go ahead. uh, that's because I'm on my dev version here.
Sure.
Right. Yeah. Usually you can go ahead and have a chat here with your model. Need to look into that what's wrong here. But yeah, you can go and chat with the model that you've just trained and see how it improved from maybe the last checkpoint or the last training that you did, and you also have a look at the validation metrics right on this UI. But yeah, LLM Studio is not only a UI tool. It has the full CLI pipeline in the background, which you could also just spawn from your terminal.
Okay, well, yeah, thanks for showing LLM Studio. If you want to test fine tuning, if you want to experiment with fine tuning, learn how to do it, where should they go? What is the URL?
It's yeah, so the repository is LLM h2o minus LLM Studio on GitHub.
Hmm.
Um, so that's where our repository is located, and where you can download the Docker or just install it right from the source files. And we also have the GPT-gm.h2o.ai as the hosted interface for our models. So that's basically where, yeah, we are hosting right now three models that have been fine-tuned using LLM Studio. And then there is also our Hugging Face page, Hugging Face h2o.ai, I believe it's called. Yeah.
Okay, and
So
if people want to say hi to you on Twitter, are you on Twitter? Where can they find you?
it's Kagling Pascal.
Awesome. Okay, well, Pascal, it's been a pleasure. Thank you so much for your time. I've really enjoyed learning about all the different things from Kaggle to GPT-4 architecture, and thank you for all of your amazing insights.
Thank you, Matthew. Thank you for the invitation. It was very nice to be here.
All right, see ya. Bye.
Bye.